Problem 67, page 289. We have 5 gram, a bullet of 5 gram, initially has a speed 400 amp per second, is fired and passes through 1 kilogram block. So here we have inelastic collision because it passes through the object. So we have directly inelastic collision. The block initially at rest, this one, on a frictionless plane, mu equals to O. Okay, if the block moves 5 centimeters to the right after impact, so the maximum compression of the block equals to 5. Here, after x equals to 5 centimeter, the block has V equals to O, is the maximum compression. We can add here the maximum, okay? We have to find the final speed of the bullet. Okay, let me explain well the situation. Now it's clear. We have inelastic collision because as I said, we have the object passes through the another object. So we have inelastic collision. So P just before equals to P just after. Okay, now we can use this relation to find something. Here, let's say just before is at this point. Okay, here we have just before. Just after is at the point. Okay, let me explain this point. We can say, let me apply before this, just before. Just before we have this system. So we have only M1 with V equals to 400 amp per second, and plus M2 has no velocity. So we can say M2 times 0. This is about the initial P just before. Just after, what do you have? We have at this position, we have the bullet is moving away, and here we have the block start to move with V2 prime, okay? And here we have the bullet is moving away with V. This is the case, we can say, here the case just after the collision, this one. Okay. And as the final case, we have a 5 centimeter of compression. The system here has V equals to O because it's the final position. And as you see here, the bullet is moving with V, the same V. Because we don't have air resistance, the bullet will continue with the same velocity to the end. Okay, so now I take just before and just after. as I said just before, we have the block and we have the bullet equals. Just after, we have this box is moving with V2 prime, and we have here the bullet is moving with V1 prime. Okay, let's say here we have V1. Okay, we can keep it V, only V. So finally we have M2 V2 prime plus M1 times V. I need to calculate the value of V. So here we can write V equals to 400 M1 minus M2 times V prime 2 divided by M1. You know, I have the value of M1, of M2. I need to calculate V prime 2. The velocity of the box just after the collision. Great. Here, what do you have? We can take, as we have an isolated system here, and between the point, here be careful, between the point, let's say here we have position A, and here we have position B. Between the point A, where just after the collision, because at the position A, we have just before and just after. Okay, at this point, just after the collision, and the position B, where we have x maximum, x equals to 5. This is the initial position and the final position. So it's very important to precise the points where you want to calculate or where you want to apply the mechanical energy. Why? Because here between initial and final state, we don't have interaction. We don't have friction between the block and the plane. Mu equals to O. So we can say mechanical energy initial equals to mechanical energy final. Initially, at this point, as you see here, you know, I want to take only M2. I don't take the system M1 and M2. Only M2. I don't need to calculate M1 because I need to calculate the value of V prime 2. So here I take the system, this one. Okay. Between this point just after the collision and the final point. Here we have initially kinetic. So here we have kinetic initial plus, be careful, here we have elastic potential energy. we have elastic potential. We don't have H between the initial and the final point. So I don't need to write PEG, gravitational potential energy. I take only the elastic potential energy. So we have PEE initial, kinetic initial, equals to KE final plus potential elastic final. Okay, at this position, we don't have compression because at this position, the initial position, we have x equals to O. So initially, we have only kinetic. So we have kinetic equals to m2 over 2 times v2 prime square plus we don't have x, so we don't have elastic potential, equals. At the final position, we don't have velocity, so we don't have kinetic. Plus, we have x equals to 5, so we have elastic k over 2 times x squared. So from here, from this equation, we can calculate the value of v prime 2. We substitute its value here to calculate v. So v, we can write here v prime 2 equals to we can eliminate 2 and 2, we get k, you know, k equals to 900 times x equals to 0.5, 5 centimeter, 0.05 square divided by m2. m2 equals to 1. Let me continue here. So v prime 2 equals to 1.5 m per second. Now we can calculate v. So v equals to 400 times m1 equals to 5 gram so equals to 5 times 10 power minus 3 minus m2 equals to 1 times v prime 2 equals to 1.5 divided by m1 equals to 5 times 10 minus 3. We calculate the value equals to 1 m per second. So this is the value of the bullet after the collision. Part B, I have to find the mechanical energy converted into internal energy in the collision or during the collision. You know, here at the position A, we have just before the collision and after the collision. as we have between just before collision and just after collision, you know the bullet go through the box. So in this case here we have friction. We lost a quantity of energy. Okay, so in this case we don't have a conservation of mechanical energy. We can say delta mechanical energy doesn't equals to O. Okay, the difference of mechanical energy equals to the internal energy. Because this quantity of energy is lost inside the box as internal energy. Okay, I want to calculate this difference of mechanical energy. I mean, I want to calculate the internal energy. We can say also, in general, you have the initial kinetic energy. I had only this quantity of kinetic energy, This energy or a part of this energy is converted to internal energy, and the last and the remaining part will be converted to the kinetic energy of the box plus the kinetic energy of the bullet final. Okay, you can solve any one of these problem. You can solve this one, or you can say also the kinetic energy of the bullet before the collision. We can say just before equals to the internal energy plus the kinetic energy just after. Okay, this kinetic energy is the kinetic energy of the box and of the bullet. Okay, now I need to calculate this mechanical energy lost here. Delta mechanical energy equals to mechanical energy final minus mechanical energy initial. Final, I mean just after. Initial, I mean just before. Okay. And you know why I don't have a conservation of mechanical energy? Because between this point and this point, we have a friction inside the object. So uh, we don't have uh, a conservation of mechanical energy. And you know, in this case, we said before delta mechanical equals to omega f. This omega f equals to E internal. I need to calculate delta mechanical. I need to calculate E internal. Okay, so I calculate mechanical final and mechanical initial. Mechanical final, what we have? We have uh, kinetic final plus potential final. And you know, as the final state, what we have at this point, we have the velocity v prime 2, and we have the bullet with a velocity equals to v, and the spring is at the position x equals to O. So we don't have elastic potential, and also we don't have a gravitational potential. We have only kinetic energy just after the collision. So here we have m1 over 2 v square. We calculate its value plus m2 over 2, let's say here v2 prime square, okay, equals m1 5 times 10 minus 3 over 2. V, we calculate its value equals to 1. M2 equals to 1 kilo. V prime 2 equals to 1.5. The answer will be 1.125 joule. Mechanical initial equals to, we have only initially the kinetic of the bullet equals to m1 over 2 times v square equals to m1 5 times 10 power minus 3 over 2 times 400 square equals to 400 joule. As you see, we have a big difference between the mechanical final and mechanical initial. The difference is we lost the difference as internal energy. So delta mechanical equals the internal equals to 400 minus 1.125. Okay, it's about 398 joule. Excuse me, here equals to 1.125 minus 400 equals to minus, it means we lost this value as internal energy. Okay,